I am back on another live, guys. My last live killed itself. As in the last live got stopped, paused. And it froze. Or, well, it went away. It just went away. I'm gonna get my food and eat with you guys and maybe sing more and maybe do a little physics, okay? So hang tight. And I hope you can find me on this live because the other one has gone away. Indeed, it has gone away. Ended itself. This one has ended itself. I'm telling the people over on the other live that ended. Hello. Hello, everybody. Are you here? I am here. Hello, everybody. Are you here? I am here. Are you here? I am here. Hello, Ryan. Hello, God bless America. Hello, Ryan. Hello. Hello. Is it me that you're looking for? I can't do an Adele very well. Hello. Is it me that you're looking for? Still should open? Oh, it's fine. Hello, Ryan. You sound more British than me. Where are you from? Hello. Is it me that you're looking for? I think Adele is British, right? So indeed it could be that I am British too. Who knows? Oh, goodness gracious me. Hello. You're a cutie. Hello, trap boy Harry Potter. Hello, Asian Josh. Hello, Jones Kastner. Hello, abusing Jets. Goodness gracious, you're not British. Did we ask you to correct us? Did we ask you? Did we request it? Hello, Hiad. Hello, Edunova. Introduce a little anarchy and everything becomes chaos. Oh, and you know the thing about chaos? It's fair. Chaos is fair. Happy National Emo Day. Hello, Hidden Edits. What's your ethnicity? How are you doing? Why did you block me? I haven't blocked you, not yet. Join us live. Come see you. Come see you is what I'll say on the live. On the live. Na maine pujhne diya ho ओ पिया ये दिया ना बुझा है ना बुझेगा मेरी चाहत का दिया. Hello, Hiad. Hello, D-Spark. Something about you is special. Thank ya. I want to follow you on Instagram. You should follow me everywhere, darling. Hello, Lewis Square. Hello, Emil. AIM music, sorry. Hello, Quetsia. Hello, Jones. Hello, something about you is special. Thank you. Hello, Xbox, Miguel. Hello, Northern South Side. Hello, Lord Chief. I ain't you, darling, says Lord. Okay. Hello, Newportio. Hello, Jason. Hello, Rondwan. She's a baddie. I am a baddie. I'm from Baddieland. What's your favorite song? Satya. Satya. That one. माधम माधम तेरी कीली हंसी साथिया साथिया ला 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 La 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 la. Ooh, can we get 5,700 subscribers? Can we? Can we get 5,700 subscribers? La 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 la. Actually, I need to get the lyrics up from this song next. Madham, Madham. This crazy woman should have millions of subs. This is very true, darling. It is very true. Like and sub. This crazy woman. This crazy woman. This girl is on fire. पीली धूप पहन के तुम एक बाग में मत आना भ्रमर तुमको सब छेड़ेंगे फूलों में मत जाना मधम मधम हंस दे फिर से सोना सोना फिर से हंस दे. Okay, I need to get my chickpeas, guys. You've distracted me from my dinner. Goodness gracious me. Hello, Lake Dawson, or whatever. Oh, Lake Dog. Let me see on my other screen. Lake Dog sent some jewels. Oh, thank you, darling. Oh, goodness gracious me. Hello, Lake Dog 229. Thank you. Thank you, darling. Thank you. Wow, 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 wow. Wow, 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 wow. I didn't misspell. Subscribe and like. I didn't misspell that, did I? Brazil. पीली धूप पहन के तुम एक बाग में मत जाना. ADHD at its finest. Ha 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 ha. Jingle bells, jingle all the way. Are you pretty? Are you petty? Over from hey! Dashing through the snow. She's so funny and silly, pretty, love it. We're in Brampton, Canada. The United Kingdom does belong to me. In my understanding of it. In my understanding. Dashing through the snow. Jingle bells, jingle all the way. What is this wife swapping that you speak of? Gentlemen, you've taken an oath, and you must abide by it. Goodness! Don't be ridiculous. Don't be. we would have a beautiful family. Family? Well, I have a family already, darling. It's made of feline children. 1 second, please. I have to get my chickpeas. 1 second, please. Do not go anywhere. I'm here. I am here. Believe it or not, I am here. See? I'm gonna make some chickpea out of this. Dashing through the snow on a one-horse open sleigh. La 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 la. Hey, jingle bells, jingle all the way. La 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 la. Hey, jingle bells, jingle all the way. La 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 la. Hey, dashing through the snow on a one-horse open sleigh. La 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 la. Oh no! Oh no! I've messed up the can opener. The part of the can that opens. Oh no! I'm gonna have to cut it. I'm gonna have to cut it tomorrow. It's fine. I'm gonna get a different can. Thankfully, I have lots of chickpea cans. Lots and lots and lots. La 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 la. Ore piya, hai. Ore piya, ore piya, hai. Ore piya. Oh my goodness, I'm so hungry. I forgot to eat. I do have ADHD, guys. I do. Family. Everything is so goopy. She's so crazy. I'm so entertained right now. A cat woman. Say some word. Say some word. She's coming. Crazy cat lady. How many times do I have to tell you that I'm not a crazy cat lady? I'm a crazy cat mother. Obsessed with my children. Obsessed. Simply obsessed. No, 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 no. It's open now. Oh, it's so cold. इतनी सुबह है रेडियो बंद करो सुबह सुबह There's a song with subah subah in it, isn't it? Somebody, what are the lyrics again? Subah subah la 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 la. Okay, excuse me please, I need to get a fork. Excuse me, kya re? La 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 le. Looks like this. Chickpea. Chickpea. A chickpea. Oh, no, no. Hello, Victor. I am so hungry right now, guys. You can chomp with me. Go get some food. Chomp a dump. Chomp with me. Get some food and eat it. Get some food. What's wrong with me? Sending you love, my darling. Adam Dolson! It's getting cosmic in here. Truly that. Your other stream is still going. Oh, good. Are you from Windsor? Windsor or something? Why do you sound so posh? Why not, darling? Okay, cool. Holly jolly. Okay. Okay, I think. Is that okay? Take your time. It's my friend. Hello, Helen. Mamma mia. I was hungry, you guys. Hopefully you're eating too. Already ate. This is a chickpea. This has 7 grams of protein. Hello, Circle of Protection. I need 30 grams? Well, that's not happening. Why did I change the name? I just did it quickly. It looks healthy. I think it is healthy. I'm just on the diet of where I don't really cook. You had to do a double take when? Oh, you tried to remember me? Remember. Am I a blood? What does that mean? Spaghetti. Spaghetti. हमको मालूम है. The streets. You should find yourself here more. Hi, Hong Wen. Sold out what? Hi, Chanel. Hello, darlings. No, baby. Shona Puji. Mama loves you, beta. Mama loves you. Mama loves you. Mama loves you. Hello, Victor. I cure man? What does that mean? Excuse me? What on earth? What on earth? Wow. I inhaled those chickpeas. I inhaled the chickpeas, guys. Inhaled. That's right. We need a super chat. What? Can we get 50 likes? Top fans are Lake Dog, number 1. Number 2, DJ. Number 3, Hung Win. Number 4, Casey. Number 5, Ryan. Number 6, Rocket. Number 7, Newport Teal. Number 8, Kareem. Number 9, James. Number 10, Elijah. Thank you, guys. Thank you, Ryan. Did you study medicine in school? Now you got a PhD. Can you share those drugs with me? I think it's because of this that my last live ended on its own. Gosh, oh gosh. हमको मालूम है इश्क मासूम है दिल से. Hello, Mr. Drew. Hello, Cassia Clobataz. Hello, Victor. Oh, can we get 5,700 subscribers? Wait a minute. Wait a minute. Wait a minute. What is happening right now? Did I share this live or not? Did I share the live? कैसी पहेली है ये कैसी पहेली जिंदगानी. No, 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 no. You guys have been most helpful tonight. I want you to know that it has been most lovely to talk with you guys tonight. पीले उसे उसमें नशा जिसने पिया वो गम में भी हंसा. नहीं 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 नहीं. No Fuji. Fuji wants some whipped cream. Fuji wants some whipped cream. Here you go. पी ले उसे उसमें नशा जिसने पिया वो गम में भी हंसा. ही 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 ही. Thank you for the gifts, guys. नहीं नहीं. नहीं नहीं नहीं. ये बातें पुरानी. Thank you. Thank you for the gifts and for all the support. Okay, actually this is not very hot. I'm gonna warm it up more. Hello Sheikh, मेरा तो दिल ही गया है तुम पर. मैंने दिल से कहा ढूंढना ढूंढला. Hello Randy. ना खुशी ना समझ आया गम तो ये गम ही सही. मैंने दिल से कहा ना खुशी ना Hey, Suji, not right now, baby. I have to soften it. La 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 la. Can we get 5 more subscribers? What the heck, guys? What the heck? Can we get 50 likes? I had to just reheat the coffee. It didn't feel warm enough. It didn't feel warm enough. Elijah! Outer space! Are you on 2 lives? I'm not really sure. One of my lives may have ended itself. Maine dil. Okay, I'm on 2 lives then. Look, I can, wait a minute. I can do effects now, guys. There's X-ray. There's retro. There's thermal. There's blue retro. There's dance party. Infrared. X-ray. Radioactive. Goodness gracious, I've never done the effects before. There's underwater. Do you guys like the effects? Dance party is the coolest. Here's dance party. Where's the party tonight? On the dance floor. Where's the party tonight? On the dance floor. It's the time to disco. Da na 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 na. It's the time to disco. Da na 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 na. Con mele dekho disco. It's the time to disco. Hello, Brenda. This one looks real. Yeah. Hello, Ryan Hawkins. Hello, Ashwin. Baji is eating a chickpea that I dropped. It do look like you have a disco ball. Do I believe if the earth is getting warmer? I do believe that there's data that the earth is getting warmer. So it's not a belief. I believe in measurements. Believe in doing experiments and measurements. I think the disco lights are bothering people. Stop saying your name? Okay. Should I do makeup? Guys, now I have a filter. This is makeup. This is the makeup filter, guys. This is the makeup filter. It's called Minimalist. This is the Dusty Rose makeup filter. Dusty Rose. I don't think I like Dusty Rose. I am going through them. This is Blush Hearts. This is Minimalist. This is Blushing. This is Plum Dusk. Oh gosh. This is Blossom Drew. This is Dusty Rose. Blush Hearts. Blushing. Once again, Blush Hearts. What do you like? Blossom Dew? Oh, good God. The filters are not as good as TikTok, is it? The filters are not really as good, right? They're not as good as TikToks. Hello, Victor, darling. I don't think I like any of them. Maybe blushing. I'll blush for a while. Baji, Paji, Suji, Fuji, Doji, Loji. Hello, darling. Thank you for the gift, Evan. Hello, Waka. I thought you were Brazilian. Thank you. Good morning to Namibia. Hello, darling. TJ. Hello, Alex. Jingle bells, jingle all the way. Can you help me meet my goal? 3 more gifts. Hello, kaisi ho khoobsurat ladki? Hello, Sheikh Kamal. She was a professor at Harvard. She's 23 years old. Oh my gosh. Batman! If I stood on that cat thing, it would break. I can't use that. Hello, Azam. I think I like the blushing filter the best. It looks the most like me. Hello, Vincenzo. Vasco da Gama. Bechara kahana. It's usually about cats and physics, but tonight we've been singing, eating, and all that. Feliz Navidad. 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 Thank you, Ryan, darling, and everyone. Okay, should we do a little bit of a reading? Let's do a little reading, okay? About black holes, star stuff. I am here. Can you see me? I am here. YouTube's been kind of sometimes ending my lives, stopping them, but then now it let me resume again. It let me resume. Do you see me? I am here. Oh, thank you guys. Schrodinger's cat. Hello, Ryan. Hello, Azam. Hello. I didn't meet my gift goal yet. Hi, Tabasum. Let's read a little bit. Aluminum occupies nearly 10% of the Earth's crust, yet was unknown to the ancients and unfamiliar to our great-grandparents. This will be in continuation of certain topics that we've been covering with elements from the periodic table. And I have now started reading a little snippet from another book of Neil deGrasse Tyson called Astrophysics for People in a Hurry. Let's see what he has to say about aluminum and the Earth's crust. Why don't we? Okay, darling. The element was not isolated and identified until 1827 and did not enter common household use until the late 1800s, until the late 1960s. When tin cans and tin foil yielded to aluminum cans and, of course, aluminum foil, I'd bet most old people still call the stuff tin foil. Polished aluminum makes a near perfect reflector of visible light and is the coating of choice for nearly all telescope mirrors today. So aluminum is important. And of course, it occupies nearly 10% of the Earth's crust. Now, aluminum, as it is found here on Earth, it's not the same everywhere else. As you know, quiz question, the most abundant element in the universe is still hydrogen, followed by helium. Okay. Aluminium, I know, it's okay. Titanium is 1.7 times denser than aluminium, but it's more than twice as strong. So titanium, the 9th most abundant element in Earth's crust, has become a modern darling for many applications, such as military aircraft, components and prosthetics that require a light, strong metal for their tasks. Okay, so different things for different stuff. In most cosmic places, the number of oxygen atoms exceeds that of carbon. After every carbon atom has latched onto the available oxygen atoms, forming carbon monoxide or carbon dioxide, the leftover oxygen bonds with other things like titanium. The spectra of red stars are riddled with features traceable to titanium oxide, which itself is no stranger to stars on Earth. Star sapphires and rubies owe their radiant asterisms to titanium oxide impurities in their crystal lattice. So, this titanium oxide does a lot. Furthermore, the white paint used for telescope domes features titanium oxide, which happens to be highly reflective in the infrared part of the spectrum, greatly reducing the heat accumulated from sunlight in the air surrounding the telescope. So this would be interesting to people who are interested in instrumentation as it relates to astronomy. Okay. At nightfall, with the dome open, the air temperature near the telescope rapidly equals the temperature of the nighttime air, allowing light from stars and other cosmic objects to be sharp and clear. And while not directly named for a cosmic object, titanium derives from the Titans of Greek mythology. Somebody here was from Greece, right? Titan is Saturn's largest moon. So by the way, Titan is also one of the giant moons of our solar system. So we have talked a lot about the solar system and I have those episodes in a playlist of mine called Planets by Oindri or something like that. And we have actually discussed, we dedicated some of the lives to just the planets and moons and the sun and all that of our own solar system. And Titan is one of the giant moons of our solar system. So is our moon, just as a side note, okay? So this titanium is kind of inspired by that. Let's see. So that was a little tidbit from Neil deGrasse's quick book here. Now, hello, Demo Core. Now let's talk a bit about dark matter in this very quick way, okay? Because this is his book, which is called Astrophysics for People in a Hurry. I think I've tagged the book. Have I tagged the book? Let me see. Let me see if I tagged it. Because I might have forgotten. Let's see. Let me go ahead and tag the book so that you know what I'm talking about. Astrophysics for People in a Hurry. There we go. I put it in there. No. Oh, there, I will pin it. Pin this product. Yes. Thank you guys for the gifts, by the way. Hello, Mehta. Hello, Azam. Hello, Mike. Thank you for the gifts. Yes. The moons. Correct. I will indeed. But actually, can we do dark matter real quick? Because I found a good spot in the book. So let's do that. Okay. Okay, so gravity, the most familiar of nature's forces, offers us simultaneously the best and the least understood phenomena in nature. It took the mind of the millennium's most brilliant and influential person, Isaac Newton, to realize that gravity's mysterious action at a distance arises from the natural effects of every bit of matter, and that the attractive force between any two objects can be described by a simple algebraic equation. It took the mind of the last century's most brilliant and influential person, Albert Einstein, to show that we can more accurately describe gravity's action at a distance as a warp in the fabric of space time produced by any combination of matter and energy. So, this is, of course, general theory of relativity that he speaks of. But of course, the first big contributor to gravitation is Newton, who was extremely unique in how well he did with that and how brilliant he was and how much he contributed not just to gravitation but also to, of course, calculus, optics, and things like that. And then in order to further make gravitation more accurate and represent reality even better, we had to have somebody like Einstein in the last century who came along and did that. So it's not an easy topic, one might say. Einstein demonstrated that Newton's theory requires some modification to describe gravity accurately. Okay, so general relativity is a correction to the already existing Newtonian theory. Of course, it's quite different than Newtonian mechanics, and he needed to develop this totally new kind of math and everything. So it's not easy in the sense of the mathematics and to put it all together. But the thing is, Newton's gravitation is fine as an approximation of gravitation if you don't care about certain relativistic details. But if you did care about it, then you would have to use general relativity. So in that sense, that is the role of general relativity. Also, I wanted to say that general relativity also made a number of very mind-blowing predictions, which a number of them have been confirmed. One of the latest ones that really stirred up, the topics was, of course, the direct measurement of gravitational waves, which are predicted by general relativity. So, those types of things make it a very strong contribution, along with being a very interesting one, of course, and it wasn't easy. Like, it wasn't simple for people to understand relativity and understand the different kind of math and geometry that you need to understand it. And because people didn't understand it well, he actually did not win the Nobel Prize, Einstein that is, for doing relativity. He got it for photoelectric effects. So I guess the moral of the story is if you develop something quite difficult for people to understand, maybe do something else that's simple that you can still be awarded and rewarded for, because relativity was not understood by most people. But it has been strong, and it has been huge, and it has boggled a lot of minds, and it has blown a lot of minds. And of course, it is successful. It is to be noted that to a large extent, it's successful. Not that it does not have flaws and further work that it might need, but it has been successful at a lot of various predictions, including the one I just mentioned, okay, along with others. So Einstein demonstrated that Newton's theory requires some modification to describe gravity accurately. To predict, for example, how much light rays will bend when they pass by a massive object. This sort of thing was actually also predicted by Einstein and then confirmed during his lifetime. So a number of predictions he was able to make and see them get confirmed while he lived, which is good, because so he knew that he was right, and whatnot. But a number of them have come about later on, and that's okay too. Sometimes things take longer to properly show and measure and confirm experimentally, because the experiments themselves, the instruments that you would need to confirm those predictions, are difficult to make and difficult to build. And so, for example, this LIGO experiment that I mentioned about the gravitational waves direct measurement, That was not easy to make. It takes time, right? And it takes a lot of money and technology and modernizing of those things to get there. So sometimes certain things can take longer. So although Einstein's equations are fancier than Newton's, they nicely accommodate the matter that we have come to know and love, matter that we can see, touch, feel, smell, and occasionally taste. We don't know who's next in the genius sequence, but we've now been waiting nearly a century for somebody to tell us why the bulk of all the gravitational force that we've measured in the universe, about 85% of it, arises from substances that do not otherwise interact with our matter or energy. Or maybe the excess gravity doesn't come from matter and energy at all, but emanates from some other conceptual thing. In any case, we're essentially clueless. Thank you, Alex. We find ourselves no closer to an answer today than we were when this missing mass problem was first fully analyzed in 1937 by the Swiss-American astrophysicist Fritz Zwicky. So this is Zwicky as in Zwicky. He taught at the California Institute of Technology for more than 40 years, combining his far-ranging insights into the cosmos with a colorful means of expression and an impressive ability to antagonize his colleagues. So by the way, we have talked about dark matter before from other books and referencing other materials, and we have done quite a bit of conversation about this. But I wanted to share with you about Neil deGrasse Tyson's perspective and the way he writes about this topic, because it's good to hear various people talk about it and kind of bring forth how they might approach it and how they might explain it. Because, you know, the way I might have explained it or shown it with, say, maybe talking about the rotation curves of objects in our galaxy, is one way to look at it, but this kind of way is also one way. Okay, so it's good to get these different perspectives, and it's good to hear about a topic more than once for us to fully absorb it. Okay, so, and Neil deGrasse is of course an astrophysicist, and it looks like he was also interested in astronomy and instrumentation and observation and things like that. And so for that purpose, we want to hear the words of many different people and their different perspectives. Hi, Fuji. Oh, Fuji. Fuji Baba is closing his eyes. Okay. Zwicky studied the movement of individual galaxies within a titanic cluster of them, located far beyond the local stars of the Milky Way that trace out the constellation Coma Berenices. The Coma cluster, as we call it, is an isolated and richly populated ensemble of galaxies about 300 million light years from Earth. Its 1,000 galaxies orbit the cluster's center, moving in all directions like bees swarming a beehive. Using the motions of a few dozen galaxies as tracers of the gravity field that binds the entire cluster, Zwicky discovered that their average velocity had a shockingly high value. Since larger gravitational forces induce higher velocities in the object they attract, Zwicky inferred an enormous mass for the Coma cluster. As a reality check on that estimate, you can sum up the masses of each member galaxy that you see. And even though Coma ranks among the largest and most massive clusters in the universe, it does not contain enough visible galaxies to account for the observed speeds that Zwicky measured. How bad is the situation? Have our known laws of gravity failed us? So this is one other evidence of dark matter, by the way, which I'm glad that he's bringing about in this book, because we have talked about some other such evidences, not this one, I don't think, in much details anyways. So, so now, so now with all this, it became quite it became quite concerning for people. Like, do we even know what we're doing with gravitation? And here we thought that gravitation was fairly well understood, with people like both Newton and Einstein contributing to it, right? So not a very comfortable state of mind for the people that thought that they understood gravitation. Newton showed that you can derive the unique speed that a planet must have to maintain a stable orbit at any distance from the sun, lest it descend back toward the sun or ascend to a farther orbit. Turns out, if we could boost Earth's orbital speed to more than the square root of 2, which is about 1.4142 times its current value, our planet would achieve escape velocity, and leave the solar system entirely. We can apply the same reasoning to much larger systems, such as our own Milky Way galaxy, in which stars move in orbits that respond to the gravity from all the other stars, or in clusters of galaxies, where each galaxy likewise feels the gravity from all the other galaxies. In this spirit, amid a page of formulas in his notebook, Einstein wrote a rhyme, more ringingly in German than in this English translation, in honor of Isaac Newton. So we will read that now. Look unto the stars to teach us how the master's thoughts can reach us. Each one follows a Newton's math silently along its path. So there we there we go. A nice little poem. Thank you, Andres. When we examine the Coma cluster, as Zwicky did during the 1930s, we find that its member galaxies are all moving more rapidly than the escape velocity for the cluster, which is pretty fascinating, right? I mean, the cluster should swiftly fly apart, leaving barely a trace of its beehive existence after just a few 100 million years had passed. But the cluster is more than 10 billion years old, which is nearly as old as the universe itself. And so was born what remains the longest standing unsolved mystery in astrophysics. Across the decades that followed Zwicky's work, so Zwicky was very important. With that measurement of his, he pretty much gave us another direct evidence of dark matter, okay? Across the decades that followed Zwicky's work, other galaxy clusters revealed the same problem, so Coma could not be blamed for being peculiar. Then what or who should we blame? Newton? I wouldn't. Not just yet. His theories had been examined for 250 years and passed all tests. Einstein? No. The formidable gravity of galaxy clusters is still not high enough to require the full hammer of Einstein's general theory of relativity, just 2 decades old when Zwicky did his research. Perhaps the missing mass needed to bind the Coma cluster's galaxies does exist, but in some unknown, invisible form. Today we've settled on the moniker dark matter, which makes no assertion that anything is missing, yet nonetheless implies that some new kind of matter must exist, waiting to be discovered. It's Neil deGrasse. Just as astrophysicists had come to accept dark matter in galaxy clusters as a mysterious thing, the problem reared its invisible head once again. In 1976, the late Vera Rubin, another very important name, okay, an astrophysicist at the Carnegie Institution of Washington, discovered a similar mass anomaly within spiral galaxies themselves. So Vera Rubin, Verarubin, studying the speeds at which stars orbit their galaxy centers. This is sort of the evidence that we have actually talked about in the past. Rubin first found what she expected. Within the visible disk of each galaxy, the stars farther from the center move at greater speeds than stars close in. The farther stars have more matter, stars and gas, between themselves and the galaxy center, enabling their higher orbital speeds. Beyond the galaxy's luminous disk, however, one can still find some isolated gas clouds and a few bright stars. Using these objects as tracers of the gravity field exterior to the most luminous parts of the galaxy, where no more visible matter adds to the total, Rubin discovered that their orbital speeds, which should now be falling with increasing distance out there in Nowheresville, in fact, remained high. So, this is what we kind of talked about in the past as well, which was really baffling, where the orbital speeds of these stars going about their galactic centers was not getting slower. These largely empty volumes of space, the far rural regions. Hi, Fuji baby. The far rural regions of each galaxy contain too little visible matter to explain the anomalously high orbital speeds of the tracers. So basically, if the most of the luminosity producing matter is not out there in the rural parts of the galaxy, like he puts it, then what is it that's causing these high speeds? Rubin correctly reasoned that some form of dark matter, as in matter that is invisible and does not interact with light, because if there was matter that we can see, as in it emits some kind of light, there's some luminosity, then we would not be so baffled. But here, we are baffled because it's dark. Rubin correctly reasoned that some form of dark matter must lie in these far out regions, well beyond the visible edge of each spiral galaxy. And remember, when we talked about our own galaxy, we saw that most of the mass that we can see, most of the luminosity producing mass of the galaxy was well within where we actually orbit our own galaxy or our own galactic center. So the behavior we expect for the stars that are farther out should be kind of consistent with that, but that's not what we were seeing. These largely empty volumes of space contain too little visible matter. Okay, so thanks to Rubin's work, which was to do with these spiral galaxies, we now call these mysterious zones dark matter halos. This halo problem exists under our noses right here in the Milky Way. From galaxy to galaxy and from cluster to cluster, the discrepancy between the mass tallied from visible objects and the object's mass estimated from total gravity ranges from a factor of a few up to, in some cases, a factor of many hundreds. Across the universe, the discrepancy averages to a factor of 6. Do I come from a royal background? Yes. Cosmic dark matter has about 6 times the total gravity of all the visible matter. Further research has revealed that the dark matter cannot consist of ordinary matter that happens to be underluminous. So it cannot be stuff that's not too bright like we thought in the past. Like it could be, like we thought, maybe this is just stuff that does not radiate or have any luminosity, like maybe the brown dwarf type of stuff, so like underluminous or non-luminous. This conclusion rests on two lines of reasoning. First, we can eliminate with near certainty all plausible familiar candidates, like the suspects in a police lineup. Could the dark matter reside in black holes? No. We think that we would have detected this many black holes. We would have detected this many black holes from their gravitational effects on nearby stars. Could it be dark clouds? No, they would absorb or otherwise interact with light from stars behind them. So this is the other thing. We talked about this, like where if you have some object that interacts gravitationally but is not luminous, you can still kind of see, because of its gravitational effect and how it bends light from stars behind it, that it's actually there, right? So this is gravitational lensing type of thing. So they would absorb or otherwise interact with the light from stars behind them if they were, say, for example, the compact halo objects that we at one point thought they could be. Could it be interstellar or intergalactic rogue planets, asteroids, and comets, all of which produce no light of their own? It's hard to believe that the universe would manufacture 6 times as much mass in planets as in stars. That would mean 6,000 Jupiters for every star in the galaxy. Or worse yet, 2 million Earths. In our own solar system, for example, everything that is not the sun adds up to less than 1/5 of 1% of the sun's mass. More direct evidence for the strange nature of dark matter comes from the relative amount of hydrogen and helium in the universe. Together, these numbers provide a cosmic fingerprint left behind by the early universe. So there is also a cosmological or a cosmology evidence of dark matter that we must also keep in mind, right? Do I believe in aliens? Hello, Ryan. So, remember also about some of the mathematics that we did, for example, for baryons and figuring out how much of each stuff there is in the energy density of the universe. This is kind of talking about that, but in more simple terms, okay? So, these numbers from the hydrogen helium in the universe provide a cosmic fingerprint left behind by the early universe. To a close approximation, nuclear fusion during the first few minutes after the Big Bang left behind 1 helium nucleus for every 10 hydrogen nuclei. So this math of the Big Bang nucleosynthesis is something we've talked about, and we have a good idea about this, and we can kind of take the measurement and compare that with observation and things like that, okay? So we kind of know what that looked like. Calculations show that if most of the dark matter had involved itself in nuclear fusion, there would be much more helium relative to hydrogen in the universe. So this is the other thing, is that we have to make sure that the prediction lines up with observation, the calculations line up with observation, and we have observational evidence of how much hydrogen helium that the Big Bang nucleosynthesis gave us. And so if we're involving dark matter in something else that we might think it's involved in, but then it does not line up with what we actually see, then we would have to be kind kind of discarding that notion, okay? So we don't think it's part of that dark matter, that is. So from this, we conclude that most of the dark matter, hence, oh, Fuji's so curled up. Fuji, baby. So from this, we conclude that most of the dark matter, hence most of the mass in the universe, does not participate in nuclear fusion, which disqualifies it as ordinary matter. Whose essence lies in a willingness to participate in the atomic and nuclear forces that shape matter as we know it. Detailed observations of the cosmic microwave background, also something we've talked about, and we've done entire episodes on that topic, so please do go find them under the live tab of this channel if you're so inclined, which allow for a separate test of this conclusion. Verify the result. Dark matter and nuclear fusion don't mix. Thank you, Isaiah. So, dark matter and nuclear fusion are not mixing either. Thus, as best as we can figure, the dark matter doesn't simply consist of matter that happens to be dark. Instead, it's something else altogether. Dark matter exerts gravity according to the same rules that ordinary matter follows, but it does little else that might allow us to detect it. Of course, we're hamstrung in this analysis by not knowing what the dark matter is in the first place. If all mass has gravity, does all gravity have mass? We don't know. Maybe there's something, maybe there's nothing the matter with the matter. Maybe there's nothing the matter with the matter. And it's the gravity we don't understand. So this is where we are at, right? Dark matter exerts gravity according to the same rules that ordinary matter follows, but it does little else that might allow us to detect it. And is there anything that's the matter with this matter? Or do we not have gravity right? Yes. So I have to use the bathroom anyways. You guys can take a look at the book that we're reading at this time. It is Neil deGrasse Tyson's Astrophysics for People in a Hurry. And we can continue once I am back from the bathroom. Hello, Matthew. Hello, God bless. Thank you, God bless America, for sending the thumbs up. Appreciate you. Let me mark the page here. Oof. Ow. Starting to get some cramps. Thank you so much, everybody, for the gifts, by the way. Really appreciate you. Intoxicated. Do you mean I'm intoxicating? You'll give me a $5 to block Matt? Aww. Why don't you both send me $5 in super chats or $500 in super chats to show your love and support? Okay, I have to go. I'll be right back. I gotta go pee. Oh, God. Also, I have cramps. So you guys better be nice to me now. You guys better watch it and be nice. Oh no, Matt. Are you spreading misinformation again? Oof, 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 oof. Shona Fuji. Hi, Shona Fuji. Mama loves you. Mama loves you. Mama loves you. Oh, Mama loves you. have the hiccups. I have the hiccups. So I need to drink some water. I am back, you guys. Oh my god. What gave me hiccups? Sorry. Can you see if my YouTube shopping link is working or not? And I can also do a different product if someone wants to try that out. Oh god. Excuse me, please. I have the hiccups. Oh. What is this? Hi, Chachi. Oh yeah, can you see Baji? Thank you for liking the live. There's Baji Papa. I don't see any money. I see the gifts. 103 gifts. $0 in super chats. 99 likes. Thank you for liking the live and sharing and subscribing. Oh, thank you for the 100th like. I appreciate you. Mwah. Okay. We will chit chat some more. And then we will resume the dark matter conversation. Oh my gosh, did someone do a super chat? Ryan Hawkins 4548 has done £5. Matt said he will match this donation. Aww. Thank you so much, guys. Oh, thank you so much for the super chat, Ryan. I appreciate you so very much. Now it says $6.69. It went away for a while. For a bit. What now? Fuji! 1 second, bacha. 1 second, Fuji. Thank you, Dialectical. Here's your kiss. Mwah. Okay. Harper says hi. No, I cannot play music because I don't own the copyrights for that. Okay. Dialectical Monist 340 has done a super chat of $6.69. Oh. Dialectical is saying, I feel bad, so now I'll do it. Oh no. Why do you feel bad? Someone promised to do it and didn't do it? Well, thank you so much. Hi, Seawag. Is something wrong with you? Why don't you take a break for like 24 hours? Yay! We don't need this kind of negativity. Thank you so much. X Power X House is saying, I need astrophysics for people that walk slow. What does that mean? People that walk slow, okay. I live in Australia and we have a social media ban that doesn't let us send money overseas anymore. How astrophysics is related real analysis in math? How is astrophysics related to real analysis in math? That's a great question. Oof, I have cramps. So there is that. Okay, so who did the super chats? Let me check again. Dialectical did it. So let me see. Where are the top fans? Number 1 top fan is Ryan Hawkins. Ryan, thank you so much for the super chat. Really appreciate you. Number 2 is Dialectical. Thank you so much, Dialectical, also for the super chat. Appreciate you. God bless America. Number 3, thank you so much. God bless for the gifts. Number 4, Asian Josh. Number 5, Victor. Number 6, Mad Moose. Number 7, Demo Core. Number 8, Lake Dog. Number 9, Alex Sanchez. Number 10, DGT. Hello, Deepak. Oof. I'm just in some pain now, but I will continue the chat and the chit-chatting hangout, and also we will continue the dark matter reading, okay? Give me a few moments to get set up.